Hi there. Ever wonder what the world was like before electricity?
It's hard to imagine not having our lights, computers, televisions, and phones.
Yeah, Jesse, the way we interact with the world must have been totally different. Perhaps the biggest difference, without electric lights, our days would be a lot shorter.
In fact, our electrified world began with Thomas Edison's light bulb. I don't think we could ever go back to a world without electricity.
In Chapter 5 of Energizing Physics, students take a welcome shift from mechanics and investigate electricity. What is it, and how do we control it?
Longer than our other chapters, we have carefully scaffolded the lessons with the goal that students understand the electrical system in their own homes. After a short exploration of static electricity and what makes electrons flow, students trace and measure current and voltage in both series and parallel circuits.
Students will complete 2 projects, building a flashlight out of household materials and writing a report on their home's electrical system for their family.
We hope you and your students have fun learning about electricity.
Some big questions in Chapter 5 include, what is electricity? What's the difference between static and current electricity? How does a light bulb work? Are the devices in your home wired in series or in parallel? Why? As you see in this example, we work to build students' ability to trace current paths to determine series and parallel arrangements. Bulb B and C are in parallel, and bulb A isn't even in the circuit. Once we have lit a 1-bulb simple circuit, students are asked to predict the ranking of these 5 bulbs' brightness. Their theories are really conceptions of how electricity works. For example, do the electrons give more energy to bulb C, the first bulb that they go through? When students wire up the circuits to find out, we then have a puzzle to understand. Why are the series bulbs so dim? During the chapter, there's repeated hands-on practice wiring circuits, observing changes, and measuring currents and voltages. Current and voltage go from abstract concepts to familiar measurements. By the end of the chapter sequence, students can analyze a challenging circuit like this, solving for voltmeter and ammeter readings A through F. Besides all the circuit wiring in class, the chapter has 2 projects. As soon as they've wired their first circuits, midway through the chapter, students can build a flashlight from household materials. At the end of the chapter, once we've learned about power and energy and circuit breakers, students can analyze their circuits and estimate the cost of each electrical device in their homes. Families like the project as students use their spreadsheet to propose a detailed cost savings plan. To recap, Chapter 5 starts with an introduction of electrostatics, spends time building mastery of circuit diagrams, current, voltage, resistance, and power, and then analyzes home electrical systems. This is one of our favorite chapters, and we hope you enjoy it too. Please be in touch as we build an energizing physics community.